Bismillahirrahmanirrahim. Dear students, class second year, grade 12, and we are talking about chapter number 13, and we are our topic is group 4 elements. We done many topics for this, and this lecture number 10 for this. So grade 12. In the previous lecture, I told you the structure of silicon dioxide and carbon dioxide. So I explained in the previous lecture. Now in this lecture, I explain the acid-base behavior of group 4 oxides. Acid-base behavior of group 4A oxides. So dear students, we have to see this. If you see my previous lectures, I'm not going to repeat again and again because there are many repetitions here. If you see the table previous, the group number 4, which we call carbon family. Carbon family means first element is carbon, then silicon, then germanium, then tin, and then lead. So carbon is a non-metal. It is a pure non-metal, so its oxide is acidic. So carbon dioxide is acidic. Acidic nature. Silicon dioxide is also slightly acidic in nature. So this acidic nature is going to decrease and basic nature is going to be increased as we go down the group. The trend of the oxides of group 4, if we go top to bottom, then there will be acidic, then amphoteric nature, and then will be a basic nature. So there are two oxides of carbon. Carbon has two oxides, carbon monoxide and carbon dioxide. Already we done the structure of these two oxides. Carbon monoxide reacts with sodium hydroxide. Carbon monoxide gas is going to react with the sodium hydroxide. You will get sodium formate. Sodium formate. It is derived from formic acid. It is derived from formic acid. It is an organic acid which is present in sting of the bees and also small ants. Formic acid. So if I remove the hydrogen and put the metal, which becomes a salt, so this is called methanoic acid in organic chemistry. So there is one carbon, methanoic acid. So this is called sodium methanoate. Sodium methanoate or sodium formate is going to be formed. Then there is carbon and silicon dioxides. Silicon has no chemical reaction with water at normal conditions, but if you use very high temperature, then maybe the chemical reaction, otherwise no chemical reaction. Now, if you are going to use the carbon dioxide gas, and dissolve in water, so it gives proton, hydrogen ion and bicarbonate ions. Hydrogen ions and bicarbonate ions are going to be formed here. So also, if you are going to detail, it forms carbonic acid. previous lecture I told you why the water become hard, why all the bicarbonates are going to be formed. So this equation I explained in the previous lectures. So this is a chemical reaction when carbon dioxide gas dissolved in the water. Because carbon dioxide gas is acidic in nature, so it can react with base also. So it can react with base, sodium hydroxide plus carbon dioxide gas. So it forms sodium carbonate and water. So sodium carbonate is going to be formed and water is going to be formed here when the carbon dioxide passes through sodium hydroxide alkalis. And if you use 1 mole of sodium hydroxide and carbon dioxide gas, you will get a bicarbonate. So maybe the bicarbonate is going to be formed in the solution. Silicon dioxide also reacts with sodium hydroxide solution, but only if it is hot and concentrated. So silicon dioxide, sodium hydroxide, hot and concentrated. This is the condition written in your book. So silicon dioxide react with a hot and concentrated sodium chloride, you will get a sodium silicate plus water. Sodium silicate and water are going to be formed when you are using hot and concentrated sodium hydroxide. This is the only journals. Calcium oxide is a basic oxide, silicon dioxide is an acidic oxide. You will get a salt that is called a calcium silicate. This is generally going to be given that basic oxide and acidic oxide give a salt. So, dear students, now we are going to come toward germanium, tin, and lead oxides. So, first I start the mono oxides. X is for maybe the germanium, maybe the tin, and there is oxygen. So, this is the mono oxides for the germanium, tin, and lead. Mono oxides. This is the X for general. So the students, they can react with the concentrated hydrochloric acid. Concentrated. So when concentrated hydrochloric acid is going to react with the mono oxides of tin, lead, and germanium, so form chloride of the germanium, tin, or lead, and water. This is going to be formed. So this is going to be formed. Monoxides. However, the lead 2 oxide, if you see the chemical reaction is given, lead 2 oxides. The formula of lead has a positive 2 and oxygen has a negative 2. So it can react with hydrochloric acid to give a lead dichloride and water. So he said that, however, the lead 2 oxide with the dilute condition. Here the dilute hydrochloric acid is given, an insoluble layer of lead dichloride is going to be formed and the chemical reaction stops. because of layer of the lead dichloride is going to form on the lead oxide, so chemical reaction will be stopped there. But when we use a concentrated hydrochloric acid, insolubility disappears and lead tetrachloride complex is going to be formed. Lead tetrachloride complex is going to be formed if we use a concentrated hydrochloric acid. This insolubility is going to be removed and you will get a lead tetrachloride. We call it tetrachloroplumbate 2. Tetrachloroplumbate. This is the name of the complex according to IUPAC system. So you will do in the chapter number 14. Okay. So how it is going to be formed? If lead oxide will react with dilute acid. So this lead dichloride reacts with more 2 chloride ions to give a complex. Soluble, we say soluble. This side for soluble is going to be formed. This equilibrium is given in book. Now, the acidic nature of the oxides. Acidic nature. Acidic nature. Acidic nature. So, if you see monoxides of the germanium, lead, and tin, and they can react with the base hydroxide ions, aqueous solution hydroxide ions. This become acidic and this is a base, and you will get the complex again. Like this one. This is going to be formed, complex ion is going to be formed with water. Like this. This the ion is going to be formed and water is going to be formed. So like sodium hydroxide solution is going to react, you will get like this one. So now dioxides. We done the monoxides, now dioxides. Dioxides. So dioxide means XO2. We done the monoxides, now dioxides. So if the dioxide reacts with the HCl, hydrochloric acid, with the acid, so you will get HCl4 and 2 moles of water. So the dioxide reacts with the concentrated hydrochloric acid. First, to give a compounds of the type of HCl4. With 4 chlorine atoms are involved. These will react with the excess of chloride. When you use excess of chloride ions, then hydrochloric acid is to be give complexes. You will get a complex for this chemical reaction. So HCl4 plus water. This is going to be water, and if the more chloride ions are going to be added, he say complex is going to be formed. This is the complex. You will get complex and plus water is going to be formed. Like germanium. Like this. With this complex you can get. If you put germanium, you will get this one. So in the case of lead 4 oxide, the reaction has to be done with the ice and cold hydrochloric acid. So if you are using lead here instead of germanium, then the condition is ice cold hydrochloric acid is going to be used. If the reaction is done with the former, the lead 4 oxide decomposed to give a lead 2 chloride. So here lead 4 chloride is taken because you know as we learned the oxidation of the lead, which is the positive 2 is the more stable and positive 4 is the least stable, and immediately the lead positive 4 changes into positive 2. That's why he said that positive 4 chloride going to be immediately changes into lead 2 chloride, and the chlorine gas is going to be evolved, and the previous chemical reaction if you see this one. So this is another also given here same point that this is an effect of preferred oxidation state. Lead positive is more stable than positive 4. That's why I say that lead tetrachloride is going to decompose into lead dichloride and evolution of chlorine gas if you see the chemical equation which are given. Now this is the basic nature, acidic. Now if you see the acidic nature of dioxides, the dioxide react with a hot and concentrated sodium hydroxide to give a soluble complex of the hydroxides. Soluble complex of the hydroxides. Like this. Hexahydroxo and maybe terminate 2, 8. We have to put 8 if there is a anion ligand, negative ligand. It's called ligand in small bracket. This is a whole complex. Hexahydroxo. Then terminate negative 2. This is a condition is given here. So if you see the chemical equation written in your book, there is an XO2 dioxide. We are talking about basic nature. So if you are using the sodium hydroxide, -1 aqueous solution, if in your book 2 times hydroxide given one, you have to cut another one. Then in water aqueous, so you will get the complex. You will get the complex SEM. This one. In your book, another hydroxide will be written, so you have to cut this. Then you have to see the equation, only hydroxide, and this will be the hot and concentrated. Hot and concentrated sodium hydroxide is a condition. Some sources suggest that lead 4 oxide. Lead is a 4. Some sources suggest that lead 4 oxides need molten sodium hydroxide. In the case, equation is different. The equation is different. So that's why lead oxide, some source suggests that if you react with sodium hydroxide with the lead 4 oxide, you will get the compound lead plumbate. Sodium plumbate is going to form with the water. This is only say that some source sodium plumbate is going to be formed here. So these are the acidic and basic nature of the group 4 elements, monooxides and dioxides. Monooxides and dioxides, and different conditions are given. According to different conditions, their chemical reactions are also different. So dear students, you have to solve the quick quizzes. 1, 2, 3, 4 questions are given here. So try to solve these questions. So now we finish. Your students, we finish here group number 4 elements. Group 4 elements we finish. Now just I will give you an introduction. Now start group number 7A elements. 7A elements. These 7A elements are called halogens, indicated by capital X. Halogens indicated by capital X. Fluorine, chlorine, bromine, iodine, and aspartame, which is a radioactive element. Aspartame is a radioactive element which is not going to participate in chemical reaction, so we will only see the chemical reaction from fluorine to chlorine. Halogen. Why we call it halogen? Group 7 elements are called halogen, and why we call it halogen? It is derived from the Greek word halios. Halios means salt former. Salt former elements. Salt forming elements. So salt forming element, just like potassium bromide, salt, bromine, sodium chloride, salt, potassium fluoride, salt, potassium iodide, salt, ionic compounds, negative charge, negative 1 charge is involved in these cases. So these are called salt forming elements. So trends in the periodic table already we done in the previous sections that atomic radius is going to be increased as we go down the group. So as you move from fluorine to iodine or aspartame, atomic size, atomic radius is going to be increased. And if you go down the group, as the atomic radius increasing, it means that electropositive character is going to be increased. Metallic character is going to be increased. So electronegativity decreases down the group. Fluorine has the most electronegative element. Fluorine is the most electronegative in the whole periodic table. Already I told you, which is a 4 according to Balmer scale. So electronegativity decreases as we go down the group. See, the table is given, graph is given for you. So fluorine is the most electronegative and iodine is the least electronegative in the periodic table according to the groups down to bottom. Electron affinity. Electron affinity means an element which has ability to attract the electron itself and form a uni-negative charge. Electron affinity is inverse of ionization potential or ionization energy. In the ionization energy, the electron is removed from the outermost shell and we need energy to form a unipositive charge. But electron affinity means the element has the ability to attract the electron and give a negative charge, and uni-negative charge is going to form, and in this case the amount of energy is released. It means that from the fluorine, if we are going to remove one electron, so this fluoride ion is going to be formed. So the amount of energy is released in this case. Electron affinity will be in the negative. Dear students, halogens have the high electron affinities and they are written here. There is the one thing. According to the told you, fluorine has the highest. But please remember it, for the electron affinities, chlorine has the highest electron affinities than fluorine due to the internal structure difference between chlorine and fluorine. So this MCQ asks, all the students they make mistake, the electron affinity, fluorine is higher and chlorine is less, but no, chlorine electron affinity is greater than that of the fluorine, and I told you that this is due to the internal structure. Then from chlorine to iodine it is going to be decreased. From chlorine to iodine the electron affinity is going to be decreased in your book, but if you compare fluorine and chlorine, chlorine is the highest. So chlorine in the group is the highest electron affinity due to the small and repulsion between the electron added and electron already present in the 2p orbitals of the fluorine. So they are different in structure. Due to this reason, that the electron affinity is going to be more of fluorine than the fluorine. Dear students, already I'm going to talk about the melting point, boiling point. Fluorine is the gas, chlorine is the gas, bromine is the liquid, iodine is solid. So this is very clear. Fluorine is the gas, chlorine is the gas, bromine liquid, iodine solid. So it means that as we go down the group, melting point, boiling point is going to be increased. So melting point, boiling point of halogens regularly increases as we go down the group from fluorine to iodine. So this indicates that more van der Waals forces, attractive forces are more prominent, very strong in this case, and this effect progressively prominent as we go down the group. Molecular size is going to be increased, and van der Waals forces, covalent forces, van der Waals force will be more strong as we go down the group. So these are called van der Waals forces you done in the grade 11 also. The physical state is going to be increased, so from the gases to the solids. So bond enthalpy, energy needed to 1 mole of the covalent bond produce individual atoms. So chlorine to form chlorine atom, and bromine atom is going to be formed also for the chemical reaction in the gaseous state. So these are the some physical properties, students. So now we are going to stop here. Inshallah, second we start the bond enthalpy of the halogens. Thank you very much. You have to see your book and revise it again, and see my lectures well, and also solve exercise questions and also board papers. Thank you very much.